Okay, today I will explain the topic related to the flip-flops. That is representation to flip-flops characters table and flip-flops excitation table. Means here flip-flop is nothing but it is a sequential logic circuit. Means that output depends on present input as well as the previous outputs. Actually, in digital circuits, we are having two types of digital circuits that are combinational logic circuits and sequential logic circuits. In combinational logic circuits, the output depends on present input only. But in coming to the sequential logic circuit, the output depends on present input as well as the previous output. The sequential logic circuit is nothing but that it is having a memory element. Maximum the examples comes under your sequential logic circuits are flip-flops, counters, and also shift registers. And these flip-flops are mostly used in your shift registers as well as the counters for the acts as a building blocks for both the counters as well as the registers. Okay. Today we'll see the what is the characteristic table or otherwise truth table of flip-flops as well as the from the truth table, how we are finding the excitation table. Why we are going for the excitation table means in order to convert from one flip-flop to the another flip-flop, we require a excitation table. Means we can convert from SR to the JK, JK to the SR. In this way, we can convert from one flip-flop to the other flip-flop by using a excitation table. And flip-flops, in flip-flops, we are using a clock in the form of a edge triggering method. It's both the in clock, in flip-flops, the output only changes whenever the clock of either positive edge raising edge or falling edge of the clock will changes, then only the output of the flip-flop changes. Here, flip-flops are a synchronous bistable devices, also known as a bistable multivibrator also. Already knew in bistable multivibrator, it consists of a two-state system. In that way, flip-flop is also having a two outputs. That may be either 0 or 1. Means here, the term synchronous means that the output changes state only at a specified point. That is in leading or trailing edge of the clock. Means the output changes only depending on the clock of the signal. In flip-flops, the clock is depends on leading or trailing edge of the clock. And in that way, in this way, in latches, the output depends on the means positive level or negative level of the level sensitive level of the clock. The changes output occurs only in the clock only. Means here we are having a flip-flops here and both in characteristic table, characteristic equation, and also excitation table. Characteristics table is consists of only here the output in characteristics table. The next state of a flip-flop is depends on the inputs as well as the present state of the flip-flop. And excitation table means here defines the flip-flop input variable values as function of the current state and the next state. And excitation table means we need to find out the exact inputs for that flip-flop when you know the inputs as a present state as well as next state. For present state and next state, for as an inputs, you need to find out the exact or mandatory inputs of that flip-flop. That is about the excitation table. And also excitation table mostly used in digital circuits for the conversion of one flip-flop to the another flip-flop. And basically we are having a 4 types of flip-flops. That is SR flip-flop, JK flip-flop, D type flip-flop, and toggle flip-flop. Totally we are having 4 flip-flops. And first coming to SR flip-flop, here we call it as a set reset flip-flop. And here we can design by using SR flip-flop. The logic diagram may be consists of a cross-coupled NAND gates, or you can use the NAR gates also for the construction of the SR flip-flop. And here TTR 74 LS100 used for the logic diagram of SR flip-flop. So IC number that is a 74LS. For NOR gates using SR flip-flop is that is 74LS0. See that here. This is the characteristics table of or truth table of your SR flip-flop. SR flip-flop means when S is equals to 0, R is equals to 0, your next state is a no change condition. Means that no change condition means the output depends on your present state only. Suppose that present state is 0, then your next state will be 0. Suppose that present state is 1, then next state of SR flip-flop will be 1. Means when S is equals to 0, R is equals to 0, now the next state or output of your SR flip-flop will be no change condition. When S is equals to 0, R is equals to 1, your output will be reset. And when S is equals to 1 and R is equals to 0, the output is set condition. And when both inputs are 1, 1, then the output will be undefined, not defined. This is a characteristic equation. We can realize that characteristic equation by using this a simplification of K-map. Means see a simplification of K-map that inputs are S, R and present state, and we are finding the K-map for the next state, that is a your output we are considering as a Q n plus n. Okay. By using this characteristic table, how we are finding the excitation table? Your excitation table is nothing but your inputs as a present state and next state. For the particular present state and next state, what are the mandatory inputs that are required? We need to calculate. See here, how we are calculating by truth table through excitation table. See here. Here we are having a presence, both inputs are there and next state is there. First see here the present state, that is a this is a present state. For present state, that present state we don't know the exact means when both are 0, 0 also, the present state is X only. Here also X only. This is also X. And this is also X. Means that may be a 0 or 1. Here also X is nothing but that may be 0 or 1. Here also that is 0 or this is also 0 or 1. See here, when this here means when the present in SR flip-flop, that S is equals to 0, R is equals to 0, when present state is 0, then your output is that is 0. Means your output depends on only present state. When S is equals to 0, R is equals to 0 and your present state is 1, then your output is 1. And that's why, and this way when both S is equals to 1, R is equals to 1, their output will be always reset only. Means that present state may be a 0 or 1, that output will be only 0 only, that is reset. And when S is equals to 1 and R is equals to 1, means that output is set. Means that present state maybe you can consider it as a 0 or 1, your output is only. And when S is equals to 1, R is equals to 1, we cannot perfectly we are not saying that output will be 0 or 1. Means that is an undefined output. Okay. From this, how we are calculating the mandatory inputs for your present state and as well as the next state. So here first condition you can see here present state, this one is a present state and this one is a next state. When present state is 0 and next state is 0, what are the mandatory inputs? See that. Suppose here first condition I am explaining, that is SR. Means that two inputs are 0, 0. See here when we are getting that inputs are 0, 0. Means here one condition is this one. Between this one is a present state and this one is a next state. Means where we which means when which inputs we are getting that present state and output as a 0, 0. And one more condition is that is This one is one more condition. Okay. Next, we are not we are not there that condition as a 0, 0. We are getting totally two combinations for the present state and next state as a 0, 0. What are the two inputs, two combination of inputs for SREs? That is, one is 0, 0 and second one is a 0 and 1. Okay. From this, see this one. Here, this S condition is a S is a both the times we are getting 0 means that mandatory input for this when the present state is 0 and next state 0 is that is S is that is equals to 0. That one is a fixed. And next when R is equals to means we are getting here different values that may be 0 or 0 or 1 means that is a that you can represent it with the X value. Perfectly, we are not saying that that is a 0 or 1 means that is represented with the X. This is a first combination. When 0, 0 means we are getting S mandatory input of S is 0 and mandatory input of R is X. This one is first condition. Next, see the when in next condition of your present state, next state is that is 0, 1. When 0, 1, what are the mandatory inputs of S? You can see that by next, see the next condition that is present state is 0 and next state is 1. What are the mandatory inputs of S and R? Means that is 0, 1. See here where we are getting that where we in which condition we are getting that Q and Qn plus 1 as a 0 and 0, 1. Here first one is see this one. One is related to Q is 0 and Qn plus 1 is 1. Only in this combination only we are getting that Q1 and Qn plus 1 as a 0, 1. Means what is that corresponding inputs are that is 1 and 0. Then that is called as a set. This is the second condition. Okay. This way next to see the next condition. Means what is the next condition that is Q1 is 1 and Qn plus 1 is 0. Here this one is a Qn and this one is a Qn plus 1 means that is 1, 0. 1, 0 means this is the one condition. And there is no another conditions. Means that next input mandatory inputs of the condition of Qn is 1 and Qn plus 1 is 0. That is a 0, 1. Means that is a reset condition. Means we are in this we are getting mandatory inputs of 0 and 1. So we see the next see the last condition of your SR flip flop that is a Qn is 1 and Q of n plus 1 is 1, 1. When we are getting that both conditions as a 1, 1 means from here to this is one condition and this is one condition. Means this one is a Qn and this one is a Qn plus 1. 1, 1 means we what are the times we are getting is that is 0, 0 is one condition and one more condition is that is 1, 0. Okay. Means here S input is nothing but here one input is one time that is 0, second time is 1 means we are perfectly not saying the value means that is equals to unknown value and R is equals to 0. Means this is the last condition of your excitation table that is equals to X 0. This is the excitation of table of your SR flip-flop. Hence, we can easily remember that value means that is S means that is 0, 1, 0, X. Means S R we will get the reverse of your S means that is X 0, 1, 0. Okay. In this way, we can find out the excitation table of your SR flip-flop by using the truth table. Next, we see the JK flip-flop. JK flip-flop. JK flip-flop is similar to the SR flip-flop, but in SR flip-flop, when S is equals to 1 and R is equals to 1, we are getting the undefined value. But in here JK flip-flop, we can, when J is equals to 1, K equals to 1, we can get the output as a toggle condition. Means toggle means that depends on the present value. When the present value is 0, we can get the output value as a 1, means that is a complement form. And when present value is 1, then we are getting the output as a 0. And the drawback of your SR flip-flop can be solved by using the JK flip-flop. Next is C. In JK flip-flop, how we are finding the excitation table. When see the first truth table of your JK flip-flop, when input J is equals to 0, K is equals to 0, your output will be no change condition. When J is equals to 0 and K is equals to 1, we are getting the output as a reset, means that is output is 0. When J is equals to 1 and K is equals to 1, K is equals to 0, we are getting a output as a set. And both the inputs are 1, 1, we are getting here output as a complement. But that is a toggle condition. See the next is the here. Here JK, next expression is there, but present state should be here. Present state that may be X only. That is a unknown value. Means you can get the two values that is equals to 0, 1. Unknown value is that may be 0 or 1. Here also 0, 1. This one is also condition 0, 1. Okay. For this Qn is equals to 0 and Qn plus 1 is equals to 0. What are the mandatory inputs in excitation table? You have to find out here. Means first condition, that is Qn is 0 and Qn plus 1 is 0. We are also first to see the when no change condition means here present state is 0 means here also we get the 2 on. 0 means we are getting 0 next state, and when present state is 1 means the next state is 1. And also see the last condition. These two conditions are maybe that may be 0 or 1 also we are getting the reset only. Here also 0 or 1 also we are getting the set only. But here last condition, that is when is A is equals to 1, K is equals to 1, we have to get the complement. Means when next present state is 0 means we are getting the next state as a 1 means, and present state is 1 means we are getting the next state as a 0. Okay. First, take the first condition as a 0, 0. See here where what are the times we are getting the 0, 0. This one it means from here to here, because here this one is a Q and Qn plus 1. Here I am considering this as a Q and this one as a Qn plus, means 0, 0 means this is one condition and this one is one condition. Okay, same. Only we are getting the these two conditions means which time this condition getting means, that is when J is equals to 0, K is equals to 0, and one more condition is that is when J is equals to 0 and K is equals to 1. Means what are the mandatory inputs for Qn is equals to 0 and Qn plus 1 is 0 means when J is equals to 0 and K is equals to X. Okay. This is the first condition. This is see the See the next condition, that is when Q1 is equals to 0 and Q1 plus 1 is equals to 1. Means 0, 1. 0, 1 means only getting here only one condition only, means that is equals to 1 and 0. Is not only one condition, that is 0, 1 is one condition in this one. And here also one more condition is there. This is the second condition. See this one here also means one set of inputs are, that is 1, 0, and one more is 1. Means the mandatory inputs of me for the Qn is 0 and Qn plus 1 are is 1 is 1 and the second one is a, this means 0 and 1 means we are getting a unknown value. This is a second condition. Next see the third condition. That third condition is when input when Q of 1 is 1 and Q of n plus 1 is 0. See where that condition is appeared. Q of 1 is 1 and Q and n plus 1 is 0. That is 1, 0 means this is the one condition and this one is the one condition. We are getting the two combination of inputs, that is 0, 1 is 1 and 1 is 1, 1. Means what are the mandatory inputs for this Q of n and Q of n plus 1 JK condition is, that is when J is equals to X and J is equals to X and K is equals to 1. Okay. This is the third condition for your excitation table. See the next one, when Q of n is 1 and Q of n plus 1 is 1, means last condition of your JK flip-flop in excitation table. See here, when Q of 1 is 1 and Q of n plus 1 is 1, means this is 1. And we are getting this is the one condition. And 1, 1 means this is the one condition. Means here from the first 0, 0 we are getting 1, 1 and also 1, 0 also we are getting 1. That is 0, 0 and 1, 0. Means here what is the mandatory input for when Q of n is equals to 1 and Q of n plus 1 is equals to 1 means that condition is J is equals to, we are getting different values, means that is mandatory input is X and K is equals to 0. This is the last condition of your excitation table. Okay. In this way we can find out the excitation table of from the truth table of your JK flip-flop. And how can we remember this excitation table means, see here 0, 1, XX. Here also XX, 1, 0 means just to reverse. First you should remember this means 0, 1, XX, that is the reverse of your, here K is reverse of your J. See the next flip-flop, that is a D flip-flop. D flip-flop we are called it as a data flip-flop also. You can find out the D flip-flop by using SR flip-flop also. In SR flip-flop, both S and R inputs are connected, considered as a D flip-flop. Means in D flip-flop, we are getting it as a output. What are the input that is having? That is only getting at the output side. When data D is equals to 0, we are getting output as a 0. When D is equals to 1, we are getting it as a 1. Means in D flip-flop, D also referred to as a, sometimes we are called it as a delay input also. See here, how we are here also, how we are calculating the excitation table from the truth table. Okay, this is the characteristic of D flip-flop. Means when input is 0, we are getting the next state as a 0. 1 means 1. Means in delay flip-flop, what is the input is there, that only reflected the output. And in characteristic equation also same as D. Means we are writing output as same as your D only. Next then how we are calculating here? Delay flip-flop, just see here. Both are 0. First see the, what is the Q? Q means we are getting next state, present state, we should know the exact, means we are having two values, that is 0, 1. This is 0, 1. Okay. Next, see here, when D is equals to 0, means your present state is 0, means we are getting next state, means when next state is 0. And also, when D is equals to 0, present state is 1, means we did not depending on here the value, means whatever the input is there, that only reflected the output. Means 0 or 1, we can get the 0 only. When 0 or 1 also, we can get the 1 only. Just to see the what are the mandatory inputs that are required for the calculation of your excitation table. See here. First condition is when D is equals to, when Q of n plus 1 is 0. And Q of n, here also we should consider the total both excitation table, that is Q and also Q of Q of n plus 1 means that is 0, 0, 0, 1, 1, 0, 1. For this, you need to calculate the what is the mandatory input of D. Means both are 0, 0. When we are getting the both are 0, 0 means that this is the only one condition we are getting 0, 0 means that is D equals to 0. And 0, 1 means Q is equals to 0 and Q of n plus 1 is 1 means that is equals to here only this condition only. This is 0, 1 means that is equals to 1. And coming to 1, 0 means 1, 0 means that is 0. And 1, 1 means that is 1. Means here totally your excitation means mandatory inputs of D is totally depend on your next state of your truth table. See here, this is the total excitation table, means Q1 plus 1 higher D is totally depend. D inputs are totally same as your next state of your D flip-flop. This is the excitation table of D flip-flop. See the last flip-flop, that is a toggle flip-flop. Next, see the next last flip-flop, that is a toggle flip-flop. Here, T flip-flop is also called as a toggle flip-flop. It is a change of the JK flip-flop. Here, T flip-flop is received by the relating the both the inputs of a JK flip-flop. Means here, we can consider T input as a, we can design by using T flip-flop by using a JK flip-flop. Next to see the T flip-flop here. T flip-flop truth table here is same as even when T is equals to 0, we are getting output as a here output as a no change, and when T is equals to 1, we are getting a complementer, means that is a toggle, means that is depending on your present state only. Your present state means what are the inputs, see here. Means here that is P1 is that is X. X means we can add that maybe 0 or here also 0 or 1. When present input is 0, what is your when t is equals to 0 means that is no change condition means that is 0 only. When present state is 1 means we are getting that is also, so no change condition means 0 1 only. When t is equals to 1, then present state is 0, where your next state will be a complementary means that is 1. And when t is equals to 1 and present state is 1 means you are getting output as a toggle means that is. Okay. This is the characteristic equation means that is equals to the T XR Q. That can be that is calculated by using a K-map simplification. And see the excitation table here. I'm here only one is there, but I'm explaining both the inputs, that is present state as well as the next state. Both are I'm considering. Means that is total you will get the two inputs means we'll get the four combinations 0 0 0 1 1 0 1. For this present state mixed state inputs, what are the mandatory inputs of that flip flop we need to calculate? Means both are 0 0. 0 0 means when we are getting 0 0 means only one condition, that is equals to t is equals to 0. And the next condition is 0 1. This one is the q1 and this one is the q1 plus 1. Means 0 1 means here this is the 0 and this is the 1. Means which condition that is equals to this is the mandatory input, that is 0 1. And next one here is next condition is that is 1 0. Here this is 1 and this is 0. This is only one possibility of input, means 1 0 means that is 1. And next one is here both are 1 1 means we are getting that is only when t is equals to 0 means that is equals to 0. This is the excitation table of your T flip flop. Please excitation table means you need to consider both the present state and next state inputs. That is 0 1 1 0. Means here this here excitation table means here T is a for first both the conditions 0 0 0 1, that is same as a no change condition is same as your next state, and this one is a complementary state. When 0 1 means this is a complementary state. When 0 0 0 1 means we are same as like your next state, whatever the next states are there, that only we are reflected here, and 1 0 1 1 in that complementary of your q1 plus 1. These are the different types of flip flops to characteristic tables and excitation table. And from the characteristic table or from the truth table, how we are calculating the excitation table. In this way, we can simply add we can calculate your excitation tables of flip flops. Let's see here. These are the different four types of flip flops and flip flops, excitation tables, and also characteristic tables. Thank you.